Hey folks, welcome to another episode of ASP.NET Core from Zero to Overkill. In this episode we'll continue our event-driven integration path with the implementation of the Outbox publisher, and to do this we'll take a look at some cool features from .NET Core, namely high-hosted services and channels. So this episode has a bunch of topics from the post that I have already been preparing. It will probably be a little bit bigger than the last couple of episodes, but I'll try to keep it as short as possible. So we'll take a look at the Outbox publisher, like I mentioned, and we'll see how to notify when the new message is stored. We'll implement something I call the Outbox listener to glue together this notification of a new message and the process that is running in the background to actually publish the messages and look at publishing the messages. Because I'm taking a somewhat naive approach to this Outbox publisher, I'm also going to create like a fallback publisher that is responsible for publishing any pending events that for some reason, for instance a server failure, didn't end up being dispatched by the main one. And at the end we'll see how to wire everything together, namely with dependency injection and all of that. Before proceeding, the usual plugs. If the videos are being useful, please consider dropping a like, sharing and leaving feedback, all important to grow the channel. And for more information, go to the blog where there are articles related to these videos. Check me out on Twitter if you have any questions or remarks. And for more contacts, there are some available on the blog and on the website. So with this out of the way, let's go. Just before starting to look at the code, let's see. You might recall this diagram from past episodes. I just adapted to what we are going to do today, and today we'll implement this Outbox publisher. In fact, there will be two, but from the diagram we had something that publishes events from the Outbox. So that's what we are going to do doing this part. This actually publishing part will come in the next episodes where we introduce Kafka and implement publishing and subscribing using Kafka. So let me go back to the list just to have an idea, and we'll start with the Outbox publisher and notifying with when a new message is stored. So in the past episode we had in the AuthDB context on the save changes, over here we had something commented to say now we need to notify that the events arrived, that the events were stored, and now we have this notify events if any, just to check if there are any events here. If there are, we're going to notify something, and in this case, like I said, just if there are some, we're calling this on new Outbox messages. So if I go here, on new Outbox messages, so this is just a delegate. The normal is people create an interface with a method, but lately I've been liking to use delegates instead of single method interfaces. Maybe just temporary thing in my head, but it's kind of I like it because it's a bit more functional and makes it clear. I could use a func. The problem is if we have more of those kinds of delegates with the same signature in dependency injection, it would be a pain and it's not as readable. If we instead use a delegate with a specific name, it's easy to do things in dependency injection, and it's clear from the name what is the point of this. So if you don't like the delegates, we could do with an interface, but instead I use the delegate injected in the constructor, and then we use it just to notify someone that we have new events in the Outbox table. And like you see, we pass in an enumerable of long, which are the message IDs that were stored. So this is it for the notification. So, but now we need to actually implement the part that is notified. So this is it for the DB context. All it does is this, notifies. And this is where the Outbox listener comes in. This is a class I created to act as the glue between the DB context notifying that something happened and some listener that is interested in knowing that the messages are there. In this case will be the Outbox publisher. To implement this, I'm using a channel from System.Threading.Channels, which are a newish thing from in .NET Core. I don't know if it comes from there, but it's well known from Golang, where they use channels to communicate in multi-threaded applications. And now .NET, from some time now, .NET Core also has this feature, which you can think of an in-memory queue for us to implement publish-subscribe or producer-consumer scenarios that are optimized for async code. So we already had things like blocking queue or something like that, but they weren't optimized for async code. Channels are, and for high performance. So channels are, for instance, used in SignalR. And that's what we're going to use. So we will have a channel of long, which is the ID of the type of the IDs of the messages. We'll create a channel here. I'll use an unbounded channel, which means it doesn't have a limit for elements, but it's probably a better idea to create a bounded channel and set up a size to avoid having a channel that grows indefinitely. But for now, I'll just go with unbounded instead of inventing some number to put the size. But as long as the consumer consumes things fast, there's no problem. But if the consumer is slower than the producer, then you could have problems and the memory growing indefinitely. But let's continue with unbounded. And we can set up some options. In this case, we can set up that we'll have a single reader, which is the case. We'll have just one publisher that will be listening for this. But we can have multiple writers. So any request that's running and stores some messages, we'll be able to notify. And by providing these settings, the channel implementation can be optimized for the scenario we have. Then, just before that, for more information about channels, there's a great blog post. I will link it in the blog, in my blog post as usual. To introduce better what we can do with channels, I'll just focus on the how I used it in this case. So for the usage, this on new messages, if you remember, the signature of the delegate was this one. It returns void and receives an enumerable of messages IDs. So this is no coincidence. This will be the method that will be injected into the AuthDB context and will be invoked. So when we invoke for all the message IDs, we do a for each and we call the channel. The channel provides a writer and a reader properties. In this case, we'll use the writer and we'll try write. Why try write and no write? There is no write, there is only try write and write async. Write async and wait to write async. So try write, if there is space on the channel, it will write and return true. If there is no space, it will return false. In this case, this will always return true because we are using an unbounded channel. That wouldn't be the case if we were using a bounded one. But in this implementation, even if I change this to bounded, I have no problem with this because this is a trade-off. I am willing to let some messages like this be lost if the channel, for instance, was full, because we'll have that fallback publisher that I mentioned in the beginning. If not, I would need to do another thing. So the trade-off is I don't care if I lose messages here because I have a fallback, to make the AuthDB context save changes faster. Otherwise, if there wasn't space, the AuthDB context would need to wait to publish the ID to the channel, and I prefer not to make the request, make the user wait longer for the request for something that I can handle in a different way. But it's a trade-off, depends on your use case and what do you feel. In this case, because I have the fallback publisher that I'll show you in a minute, I don't care if the messages is not published. That's why I'm just try write. If not, I don't care. I'm just logging to have some information of what's going on, and we can adapt the code to our needs. And that's all for the publishing. For the reading, we have methods similar to this in the reader. If I go here, we have try read, wait to read, read async, and we could implement it like this. But there's also this read all async, which returns an async enumerable, which is a new thing from .NET Core 3.0 and present in .NET Standard 2.1, which allows us, it's like the name implies, it's like an IEnumerable but for async. So we will able to use a newish C# feature, which is called await for each, and it simplifies our code of consuming things. So we could consume things in another way, but this is just easier. So what I'm doing here is just read all async and returning and use this. It might seem a bit abstract right now, but we'll see the usage in a bit. So let me see. Okay, so right now. So this is the listener. It's just something that glues together, something that notifies and something that needs that notification. And what needs that notification, we'll introduce here, is the Outbox Publisher background service. So this class, which inherits from BackgroundService, which is an abstract implementation of IHostedService, the thing I mentioned in the title of the video. So this is a way to implement in .NET Core hosted services. For instance, the web server is a hosted service, but we can also run other things that we might want to run for the whole lifetime of the application, or maybe just a bit. But for instance, if we want to have something listening in on the queue, this is the way we would do it. In this case, we'll host an in-memory queue using this. The background service is just an abstract class that has some helper things. So it implements the start async and stop async. And we just need to implement this execute async and return a task. When this task is completed, means the service can go down. In our case, we don't want ever to complete a task unless we have an order for the service to go down. So going back to the publisher background service, this service is just responsible to be running in the background and grabbing the message IDs that come from the Outbox listener and putting them into the publisher. So that's why we get the publisher and the listener. And on execute async, all we do is await for each, like I mentioned before, on the listener with that method get all message IDs async. So this is basically it's like a loop forever until nothing else gets pushed on the channel, which is normally will only be closed at the end of the application. So while the channel is not completed, this will stay here and wait. It will be here and wait for the next message. As soon as we get a new message, we go here and we call publish async on the publisher, which will be responsible for reading the message from the database and publishing to the event bus. that final part for the next episode. Just a note that I added here. One message at a time is probably not great because we'll read one message from the database and publish, one message publish. If we could batch, if we have no load, there's no problem. But if we have load, it's better to batch. So we read a bunch of messages from the database and publish a bunch of messages instead of one at a time. It's more efficient if we do it like that. But for now, I'll keep it simple. So I just dropped the comment so we remember this fact. And that's all this background service does, is be running as a background service, listening for new messages, and passing them on to the publisher. So now we can go and check out what's going on in the publisher. Before that, just again, docs are your friend, so there is good documentation on background tasks with hosted services in ASP.NET Core. I'll link it in the post. So for the publisher, this does what it does, what the name says, just publishes the messages. So we have this publish async method, which gets the message ID and the cancellation token as usual. This part is a bit ugly, but it needed to be this way because the Outbox background services that we saw earlier, this will be running for the whole lifetime of the application. So it's basically a singleton, and it's registered as a singleton in the DI container. So this brings a problem because the publisher has a dependency on the database context. And as you might be aware, the database context shouldn't be opened or shouldn't be the same instance for a long time because the change tracker keeps information about the entities it manipulates and stuff like that. So normally the DB context is used in like a scoped associated with a request. We get a request, use the DB context, and at the end of the request we get rid of the DB context. Because this is not in a request scope, we need to do it manually. We could do it in the background service, or we can do it here. Just to abstract that need from the background service, I put it here, but don't know what is the best place. And I'm using this service scope factory directly. Maybe I could use create an abstraction factory. In this case, don't care. I'll just go directly here, but maybe we could make some improvements. So we create a scope and we do using on the scope. This is a C#8 feature, the using expression, how is it called? Let me see. Using declaration. So we can do this. Some people don't like it, like to put the curly braces. I happen to like it if it's clear. In this case, I think it's clear. We are starting it here. When the method ends, the scope will be disposed. And everything that we ask from the scope, in this case, the authDB context, will be disposed with it. But if you don't like this, just do a normal using and put the curly braces. After getting that DB context, we can actually go to the logic. So we have a transaction here, and this is because even though we have a single publisher on this machine, we may have multiple publishers on multiple servers, containers, whatever. So it's not impossible that some other publisher grabs the same messages as we are handling for some reason, and then we would publish multiple times the same message. That can happen anyway, but if we can avoid it, I think it's good to avoid to publish the same thing multiple times, and that's why I'm doing it like this. So creating a transaction, then go to the database and find the message with the ID provided. Immediately after we get the message, we try to delete the message. And why is that? Because this is the way we set it as removed and we save changes. It goes to the database, but because we're in a transaction, even though it went to the database, it's not committed, it's just in the database. So if another publisher tries to delete the same message, it will be locked and it will have to wait until this transaction ends. If this transaction ends with a commit, then the other transaction from the other publisher will fail and will not publish the same message because this one already handled. If this rolls back, then the other publisher can continue what it's doing. And that's why I'm doing it like this. Called it try remove and returning a boolean. If the delete was successful, then it will return true like we see here. Otherwise, we catch the big update concurrency exception, which is what is thrown in cases where 2 or 3 publishers try to delete the same messages at the same time, and in this case we just return false. When we return true, we go into here. If we return false, just roll back and move on. But if we return true, this is where publish the event. In this case I'm just logging, but in the next episodes I will replace this with an actual publish to Kafka. And finally, commit to say what we pushed into Kafka. We can delete, so we can commit the delete that we made before. And that's all. It's not a lot of code, but it's not trivial code. So if I messed up something, or if you don't understand something, please drop a comment asking or recommending fixes. But that's about it. And as we'll see, the fallback publisher will be very similar, but instead of using this message ID, we'll have another strategy. But this is basically the strategy, to try to publish messages with as less repetition as possible. It is always possible, but we try to avoid it as much as we can. So this is it for the Outbox publisher. Far from trivial, as I mentioned, and just a friendly reminder, many of these things are solved in frameworks and libraries. Don't know if this exact behavior is done, but similar things, trying to solve the similar problems exist. So if you can avoid doing these things, go for it. Otherwise you have some idea of the problems you'll face when implementing these kinds of things. So I think for the publisher that's all. Let me just check here. Yep, notification, the listener, which is the glue, running in the background with the background service, and publishing an event. So, and with this we already saw the channels and the IHostedService in action. So let's implement the fallback Outbox publisher. And think of this, that I'm probably very likely over engineering. Instead of doing these two, we could get away, for instance, with just this one and not do this. So basically what I'm doing is this Outbox publisher, which we saw right now, it's like a latency optimized. So as soon as we know there's messages, we are sending them. So we want to publish the messages as soon as possible. This fallback Outbox publisher, on the other hand, is more reliability oriented. So it will be based on polling. So it will from time to time check the database and see if there are messages pending. And if there are, they will be published. So this would be good enough. The only problem is it will take a bit longer for the messages to be published, because they will be only published after some time. But this could be tweaked and probably would be good enough. But in that case, we wouldn't have the opportunity to play with all the things we're playing in this episode, and that's why I'm going with this. But as the name of the series says, overkill, and I'm probably going overkill. So let's look at the fallback Outbox publisher. Going here, we have the fallback Outbox publisher. As I mentioned, the logic is very similar. We have some constants here, we will see in a bit, but for the rest, we have this publish pending async, which is the method the only public method of this class, which will try to publish all the pending messages that we have. And I'm doing that in a while. And this publish batch async returns true if there is another batch to publish. So while there is a new batch to publish, it will iterate. Then over here, this publish batch async is very similar to what we just saw for the normal Outbox publisher. We create a scope, get the DB context, create a transaction, and then we do this get message batch. We'll go to the implementation in a bit, but just know that it gets a number of messages that are considered pending and that weren't sent by the normal publisher. So if we have messages and try delete succeeds, try delete is exactly the same as before, then we send all the messages and commit. This is all the same as before. Only difference here is we return if there is a new batch available. So the while loop continues. So this is basically an optimization. Instead of waiting for some time and then publishing another batch, if we know there's another batch, we can just publish and keep publishing until we have all the messages published. So, as for the differences between this and the other publisher, we have this get message batch async, which we'll see. It uses a message batch query because it's reused in these two, but basically it just says go to the database, check for the Outbox messages that are created at and a time that's less than get minimum message age to batch. So what this means is I have defined here this minimum age to batch, which is 30 seconds. So this is an assumption that if the message is in the Outbox table for more than 30 seconds, then probably the normal publisher failed for some reason and we want to publish this pending message. That's the assumption. So that's why we are considering the messages pending that fulfill this criteria. So in the case of get message batch async, it just uses that base query, takes some amount of messages. In this case I put 100, but we can change that to what makes more sense to increase our throughput, and to list. Over here we get the batch and do what we already saw, and in the end to return if there is a new batch we use the same base query and just check if there is some message in there. If there is some message, it means instead of stopping we can, or sleeping, we can just return, continue the loop immediately to publish everything. And that's it for the publisher. So it's far from trivial code. It's not big, but it's far from trivial, and that's why I kept things separate in several classes to keep this kind of hard logic in one place and move the other things in other places. Going here to the list, what we're missing is scheduling the execution of this publishing. So this publishes all the messages that are in the Outbox, but what invokes it is this Outbox publisher fallback background service, so giant name because reasons. So it's another background service like the other we saw, but in this case there is no listener to notify it that there are new messages. This is polling based, so because it's a fallback in this case. So what we do is, while there is no cancellation requested, we continue calling the publisher to publish any pending messages, and it executes that code we just saw, and at the end we just task delay, so we wait for 30 seconds, whatever, before checking again, just so we avoid hammering the database. We could just continue querying, but that would not be very smart, and the database would probably not like. So this is it. So with these 30 seconds, I think you can understand why the other one is latency optimized. So with the other publishes everything immediately. This one is just a fallback checking. Is there something pending? There is. I publish. Otherwise, keep going. In the normal execution, this would normally never run, or this would normally never publish anything because the other publisher would handle everything. But there might be failures, and like I said earlier, the other implementation is kind of naive, so I'm not handling retries and weird errors, something like that. No, I'm just not caring because eventually this publisher will try. So we have some guarantee that eventually all the messages will be published. That's not to say this is perfect, far from it. There are probably a ton of things to do better, but at least because we have this fallback, it works. And like I said, regarding the overkill part, maybe we didn't need the other service, the other publisher. This one maybe could be good enough. We could make it less time between loops, so and the latency wouldn't be as bad. But like this, we had the opportunity to play around with a bunch of things. Going back to the list. So now let's look at wiring everything together. So over here, I have in the version of control, I have a class with helper methods to register event related stuff. And this part was already here. It's to register those event mappers. And for today, I registered this listener, publisher, and fallbacks publisher, which are normal singletons. This on new Outbox messages, as you might recall, is that delegate. And because that delegate, the implementation is the method from the Outbox listener. To do it, it's a singleton, but then we use the factory or the func version, where we can go to the service provider, get an Outbox listener instance, and then return the method. So what will happen is this method will be injected in the AuthDB context. This is the only part I think it's a bit different from usual. As for the rest, just normal register singletons. And remember, that's why I needed to do that trickery with the DB context, because the DB context shouldn't be inside the singleton and should be disposed earlier. For the hosted services, we have this add hosted service extension method where we provide the services, and that's what we are doing. If we look inside, it's basically adding a singleton instance of an iHosted service. So we could do it manually, but there's the extension method, easier for us. And that's all. With these wiring things, everything works together. Just to see things working, we can run the application. Over here, check the logs, and if we go here and rename again because of reasons, if we go here, somewhere, there is here, so Outbox publisher, event with ID, stuff, published. So that's all. So it was, I think it was bigger episode than the past ones. I am trying to get things smaller, but this is not an easy topic. And I introduced a bunch of things, namely background services in channels and all those transactional stuff. So it was a bit more hardcore. So as usual, feel free to ask any questions or do some comments. Maybe I can improve this, or open issues on GitHub. That's also available. So we can improve this eventually at some point. That's all for this episode. I hope you enjoyed it and hope to see you in the next one. See yous!